which means they have the same value. Okay, an inequality is a statement that two sides are unequal. And it tells which is larger or which is smaller, depends on how you look at it. Okay, so this is what an inequality is. So these are the symbols for inequality. This symbol is read is less than, meaning the value on the left is smaller than the value on the right. Do you guys remember like the mouth eats the bigger number? Guys, yeah, okay. This one is greater than. Okay, now it's important with the word is in there, because if I just say less than, I'm talking about subtraction. Is less than is talking about inequality, because is means equal in math, and so this is like telling you that it's equal less than. It's not equal, but it's telling you that we're using like a symbol, like that would be in the place where an equal sign would be. Does that make sense? Okay, here we have a less than symbol and an equal symbol mixed together to get is less than or equal to. Okay, which means that whatever's on the right is less than or the same as whatever's on the left. And we don't know which one it is. It could be the same or it's going to be less than. Over here, this is greater than or equal to. Okay, now with these, it has to be strictly less than or strictly greater than. So if on this side I had a 2, this side could be 1.99999 forever, but it'll never be 2. Over here, if this is 2, this could be 2 or 1 or 0 or negative 5,000. So it can be 2 or it can be less than 2. This one, it can never be 2. Does that make sense, the difference between them? Okay. So we have examples of inequalities. 5 is greater than 3. And 6.8 is less than or equal to 6.8. Because the equal to makes it true. I could never say 6.8 is less than 6.8, because that's not true. That equal, though, makes it true.
What could you say is less than or equal to? It has to be greater because it's the same thing, right?
No, I could also see 6.8 is greater than or equal to 6.8. These are both true. What we're going to end up with in our practice is we're going to end up with x is less than 5, or y is greater than or equal to 7, or x is greater than negative 3, things like this. We're going to be solving to get down to statements like that, where we have a variable on one side, a number on the other. And what this tells us if x is less than 5, x can be 4.9999 whatever, and anything below that. It just can never ever be 5. And here, y is greater than 7 tells us y can be 7, 8, 9, 10. Yeah, greater than or equal to. So it can be 7 or bigger. It has to be less than 5. It can never be 5. So that's the difference between the two. We solve inequality by addition or subtraction. This is the same as solving an equation. We're going to do the opposite of what's already there. So if they added, you subtract. If they subtracted, you add. We have what's called the addition property of inequalities, which tells me that if A is less than B, then A plus C will still be less than, not A again, B plus C. Or if A is greater than B, A plus C will be greater than B plus C. So if I have two numbers that are in a relationship, one's larger or smaller than the other one, if I add the same number to both sides, it doesn't change. And just to show proof of this, 3 is less than 10. You guys agree, right? Everybody agrees? 3 less than 10? Okay. 3 plus 2, 10 plus 2, 5 less than 12? Still the same, right? So adding the same thing to both sides doesn't change that relationship. X minus 12 is greater than or equal to 8. Okay, to get rid of this minus 12, I'm going to add 12 to both sides. Just the same as if there was an equal sign here. It's greater than or equal, nothing changed. It stays greater than or equal, and it becomes 20. Okay. Doesn't matter what side we're on, m minus 8. I'm going to add 8 to both sides. So 22 plus 8 is 30 is going to be greater than m. Or if you don't like your m's or x's or whatever on the right-hand side, you can put it out front, but if the arrow is pointing at the m, the arrow has to stay pointing at the m. Okay, so if you move your variable to make it look prettier, because you like it in the front, remember that it needs to point at the same thing that it was pointing at before. Does that make sense? Yeah.
So we're not changing whether it's greater than or not, we're just solving it and leaving it like that.
Yep. Yeah. So here this is telling me 30 is greater than m. That's the same thing as m is less than 30. What I couldn't do is then change this and make it m is greater than 30. That would not be true. Does that make sense? Okay. Subtracted 14, so if I add 14 to both sides, and you'll notice this 19 is negative, and that does not matter. I just copy this down exactly the way it was. I don't change anything. Now, we talk about something called set builder notation. This is formal mathematics. Okay, so for set builder notation, you put X or whatever letter you're using, a bar, and then your solution. Okay, and this reads X such that. So if I did X set builder notation for this problem, it would be X such that X is greater than or equal to 20. If I did set builder notation for this one, M such that M is less than 30. I should make that blue again so it stands out. M such that M is less than 30. D such that D is less than or equal to negative 5. Now with set builder notation, it always needs to be, your solution needs to have your variable first. So you could technically write M such that 30 is greater than M. It's just not technically pristine. And since if you're doing set builder notation, you're trying to be formal, so you want to put that variable in front. When we talk about graphing inequalities, if we use less than or greater than, we graph with an open circle. And if we use less than or equal to, greater than or equal to, I totally said those backwards, we graph with a closed-in circle. Okay, so if I were to, for example, say y is greater than 5, I assign some point to be 0. 1, 2, 3, 4, 5. It's greater than, so I draw an open circle, and then I shade everything that is bigger than 5. Okay, now the open circle tells you that it doesn't include 5. It includes everything up to 5, but not 5. Whereas if I did y is less than or equal to 3, I pick a 0 anywhere, 1, 2, 3, closed circle because of the equal sign, and then shade everything that is less than that. So we're going to graph our solutions. We had x is greater than or equal to 20. M is less than 30. And D is less than or equal to negative 5. Yeah.
On the worksheet you gave us, do we solve before we graph?
So x is greater than or equal to 20. I am going to call this line right here 20. I can call this line over here 0. It doesn't really matter because these could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, I maybe should have been one more over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are by 2s, 2, 4, 6, 8. Greater than or equal to, so I'm going to have a solid circle or an open circle?
Solid.
Solid. And then I'm going to shade that. And it doesn't even have to be pretty. M is less than 30. If I call this 0 and I say these are 10s, 10, 20, 30, doesn't matter. I can do that. I can do open circle because it's just strictly less than, and less than is over here. Now, if your letter is in front, the arrow will point which way to shade. But remember what we had originally got was 30 is greater than M, and that would not have pointed the right direction. So you can only trust the arrow is pointing the right direction if the variable is in front. 1, 2, 3, 4, 5, 6. I'm going to say that's 0. 1, 2, 3, 4, 5. That's negative 5. D is less than or equal to, so it's a solid. Goes that way. Just like we can add the same thing to both sides, we can subtract the same thing to both sides. So if I say A is less than B, and I subtract the same thing from both sides, it's still true. Or if I say A is greater than B, I can subtract the same thing from both sides. It's still true. So 3 is less than 10. We'll use that same example. If I subtract 5 from both sides, I get negative 2 is less than 5. This is still true. So same as adding, I can subtract from both sides. Doesn't change anything. I mean, it doesn't change the inequality. So M plus 18, so they added, I subtract. And I get M is greater than 38. Okay. In set builder notation, M such that M is greater than 38. I will call this 0. I only go up to 30 if I count by 2s. I'm going to count by 5. So 5, 10, 15, 20, 25, 30, 35. I'm going to say 38 is about right there. That's fine. It's greater than, so it's an open circle. And I shade this side. That was M greater than 38. If I have P plus 8 is 8, I subtract 8. P is going to be less than or equal to 0. So pick a line to be 0. It's less than or equal to, so that's a solid circle. Solid. And I shade this way. There, I got lazy. I did, yeah. Negative 7 is greater than 20 plus C, so I'm going to subtract 20 from both sides. I get negative 27 is greater than C. It's another good reason to cross your 7s so they don't look like greater thans. Actually, I should write that in black so it stands out. 27 greater than C. So to graph this, I can leave it like this. I'm going to call this negative 27. It's going to be an open circle because it's a greater than. Now, 27 is greater, negative 27 is greater than C. So which side will I shade? Right or left? Left, right? Because we want to be what's less than 27, since 27 is greater. Good? Variables on each side, that's fine. We're still going to add or subtract. We're just going to happen to, I don't know why I put all this space. I just put solve the same. Okay, if they add, we subtract. If they subtract, we add. We're contrary that way. Okay, so, but I want the number by itself and the variables together. So I have 3a plus 6 is less than or equal to 4a. So I'm not going to subtract 6 from both sides. I'm going to subtract 3a from both sides to get it with the 4a. So 6 is less than or equal to a, which is the same thing as a is greater than or equal to 6. I'm going to say this is 6. This is 0. Greater than or equal to, so I have a solid dot, and I shade this way. Nine n minus 1 is less than 10n. I'm going to subtract 9n from both sides, and I get negative 1, negative 1 less than n, or n greater than negative 1. So if I call that 0, I call that negative 1. It's going to be an open circle. And then greater than is this way. Five h is greater than or equal to 12 plus 4h, so I'm going to subtract 4h from both sides. And I get h is greater than or equal to 12. Open circle or closed circle?
Can you explain the open circles and closed circles?
Yeah, if you have greater than or less than, you're going to do an open circle. If you have equal to's, you do closed. This difference in the circle, this circle means that it doesn't include the number you've circled. This circle means it does include it. Okay, so I'll say this is 0, 2, 4, 6, 8, 10, 12. Closed circle, greater than. Questions on those at all? Felipe needs for the temperature of his gecko's basking spot to be at least 82 degrees. Now, okay, let's look at this word at least, or this phrase, at least. That's not the pen I want. That's the pen I want. Okay. At least means that it's that much or more, right? Because if I have at least $5, that means I have $5, but I could possibly have $10, $20, right? So it sounds opposite of what it actually is. It's greater than or equal to. At most would be less than or equal to, because if I say I have at most $10, that means that the most money I have is $10, but I could possibly have less than that. So it's backwards from the way it would sound. So at least is greater than or equal to. So it needs to be at least 82 degrees. Okay, so we're going to do at least 82. Currently, it's 62.5. Okay, so we want to know how much warmer does it need to be. So 62.5 plus however many degrees we add to it needs to be greater than 82, greater than or equal to. Does that make sense? Yeah? Okay. So we're going to subtract 62.5 from both sides to get that x needs to be greater than or equal to 19.5 degrees. So we're going to need to raise the temperature at least 19.5 degrees. And then 0, I'm just going to say this is 19.5. There's no rhyme or reason to it. It doesn't really make sense, or I don't really care. As long as you tell me 0 and you give me the right number and it's on the correct side. Closed circle, greater than. Okay. So if he's bought this t-shirt and a belt and he wants a pair of jeans and he only has $65, we first have to add these together. So that's 32. We subtract the 32 from both sides. And the most he can spend on the pair of jeans is $33. So it has to be less than or equal to $33. I'm going to say this is 0. I'm going to say this is 33. Again, it's arbitrary. And I'm going to draw a closed circle because he can spend up to $33 because we're pretending there's no tax. And so his jeans has to be less than or equal to $33. Let's look at just if we have an inequality. Let's say 4 is less than 12. Okay? And I multiply both sides by a positive 2. Oops, not 4 times 2 twice, 12 times 2. Right? 4 times 2 is 8. 12 times 2 is 24. This stays less than. That stays true, correct? But what happens if I take this same inequality and I multiply it by negative 2? This is negative 8. This is negative 24. Which one is greater?
Negative 8.
Negative 8. So multiplying by negative actually changes the truth of the inequality. So 8 is less than 24, but negative 8 is greater than negative 24. What we've done is we've taken our inequality and we've flipped to the other side of the number line when we multiply by negative. Because everything on the negative side goes backwards, so we're flipping.
You want us to flip it or just try to like it?
Flip it. That's my pretty picture for flip. What do you think? Does that look like I flipped? No? Oh, darn.
It's more like a dive into a pool.
Well, right, I flipped. No? Not good? Okay, I flipped.
Make a U-turn sign.
That goes like this, right? I don't know what a U-turn sign looks like.
I'll make it upside down U-turn sign.
Like that? I flip? All right, we'll stick with sideways.
It's gonna get it.
Flip. There, we'll just write the word. Okay, so the multiplication property of inequalities tells us that if A is less than B and C is greater than 0, so it's positive. If I multiply by C, nothing changes. But if A is less than B and C is less than 0, so it's negative, then AC becomes greater than BC. Okay, so the rule is if you multiply by a negative, flip your inequality. Okay, and I mean it makes sense, right? Why you have to do that? Because it changes the truth. Multiplication. 6 is positive, so I'm going to be multiplying by a positive 6. So my inequality will stay the same, and and I am 78. So x is greater than 78. In set builder notation, x such that x is greater than 78. And if I'm going to graph this, I'm going to say this is 0. I'm going to say this is 78. I have an open circle. And I'm greater. Okay. 5 is positive. Now 3 is negative. Does that matter?
Yes.
No.
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 That's why I put this one up there. It's only the number that you're physically multiplying. The 3 was already there. I'm not doing anything with the 3. It just happened to be there. But this 5 that I'm multiplying is positive, so it doesn't change. Okay, so the number that's over here can be negative and it doesn't mean anything. The 5 was positive, so no change. Okay, so I've got set builder notation m such that m is greater than or equal to negative 15. I'm going to graph that over here. I'm going to call this 0. I'm going to call this negative 15, just so long as it's on the right side. I don't care if it's perfect or not. I have a closed up circle because it's or equal to, and then it's greater than, so I'm shading this direction. So far, okay? Now here, this is where I have a negative 6 that I'm multiplying by to get rid of the negatives. So this is negative, so I have to flip. I don't want a red n, I want a black n. So n is now going to be greater than or equal to negative 48. Yes.
So even if you have a negative, even if that had been negative 8,
it would still,
then it become a positive,
it still would have flipped because the 6 that I multiplied both sides by was negative. So you're looking at what you're multiplying both sides by. So it doesn't matter what's over here already. It can be negative or positive. That part doesn't matter. It's only this part that you look at that matters. So since this was positive, it stays the same. Since this is negative, it changes. Does that help? Hold on. Same thing. Okay, set builder notation. And we're going to graph it. Well, these ended up being greater than. Okay. Again. And greater than or equal to negative 48. So I'm going to say this is 0. I'm going to say this is negative 48. Open or close circle? Close circle. And shade this way. Multiplication is like division. Same idea. If I have that 8 is less than 12, and I divide both sides by 2, not 8 divided by 2, 12 divided by 2, I get 4 and I get 6, and that's still true. But if I have 8 is less than 12, and I divide by negative 2, I get negative 4 and negative 6, and we're now this way. Because negative 4 is greater than negative 6. Yeah?
Why are you dividing if the 8 is less than 12?
I'm just saying this is what happens if I divide both sides by a negative. This is not like a problem to solve.
Yeah.
I'm just showing that if I divide by a positive, it stays the same truth value. But if I divide by negative, I changed it. So if we divide by negative, we end up flipping the inequality. Same as multiplying. So the division property tells me that if A is less than B or greater, and C is positive, A divided by C will stay less than B divided by C. But if A is less than C and C is negative, A divided by C is greater than B. Oops, that should be a B. B divided by C. And that looks like an E. Wow. Can't write today. Okay, so just like with multiplying, if you multiply by a negative, you have to flip the sign. If you divide by a negative, you have to flip the inequality. Okay, we can add and subtract all day, and it doesn't change anything. That never changes the inequality. It stays the same. So adding and subtracting never changes anything. Multiplying and dividing positives doesn't change anything. It's only when you multiply or divide by a negative that you have to flip the inequality. Here I'm going to divide by 8, which is a positive. So since I'm dividing by a positive, nothing changes. 8 doesn't go into 58.
We're gonna 56.
Yep, that's okay though, because this would be 29 fourths. This is a good example. I divided them both by 2. I reduced the fraction. So my set builder notation is P such that P is less than 29 fourths. And guess what I get to do? I can say this is 0, and I'm going to say this is 29 fourths. It's arbitrary, right? I can make these numbers anything I want them to be. And it's an open circle. And I shade less than. So should you get a fraction, don't go, oh my gosh, I don't know how to graph that. Just write it down. You're good. As long as it's on the correct side of the 0, that's all I care about. Okay? I'm dividing by 6. The 6 is positive. The negative 42 doesn't matter. I'm only looking at what I'm physically dividing by, so it's negative 7 is greater than R. In set builder notation, R such that R is less than negative 7. Now I didn't flip anything, it just, the arrow still points to the R. So this was P is less than 29 fourths. This is R is greater than negative 7. I'm going to say this is 0. This is negative 7. It actually is. Open circle, because I'm just plain greater than. Well, that sounded really stuck up. I'm just plain greater than. I meant my number is, not me. Okay. And then here we're finally dividing by a negative. So we're going to flip our inequality because we're dividing by a negative, and D is going to be greater than or equal to negative 21. Okay. So this is negative. So we flip. Yeah.
The rule is that whenever you divide or multiply by a number and it's a negative, the negative carries to both sides. Is that
Yes.
like a rule in all
Yes.
of algebra?
Yes. If you multiply or divide by a number, if it's a negative number on one side, you're multiplying or dividing by a negative number on the other side as well. The only time the sign changes is if I were to say, pick this 7D up, like this negative 7D, and I just lifted it up and I stuck it on the other side, it would become positive because I changed sides, but I wasn't dividing. I could. I wouldn't do any good in this scenario. I'm going to show you guys some things later where that is a useful tool. Yeah, it does. It works with adding and subtracting. Yeah. So this is 0. This is negative 21. D is greater than or equal to it, so it's going to have a solid circle, and it's greater than. It's a matter of comfort. Which one do you think is more comfortable? So here's one step. I showed you this, I think, also with the regular equation, 2 steps. Okay, so if I have negative 4/3, P is greater than negative 10. I'm actually going to take these graphs out because there's just not enough room. I don't want to be too crowded. Okay. In one step, what I'm going to do is I'm going to take the reciprocal of this and I'm going to multiply it by both sides. Okay. Now, these two will cancel each other out. The 4's cancel, the 3's cancel, the negatives cancel, and so I'm left with P. 4 does not go into 10, but they'll both divide by 2. So this becomes a 2 and this becomes a 5. Does that make sense? And then negative 3 times 5 is negative 15 halves. So that was in one step. Yeah.
Couldn't you also like times the 3 by each other and times the negative 10 by 3? And
Yeah, I could.
Negative 4p is greater than negative.
That's
10
what I was going to do in the two-step right here. Yeah. Yeah. In the two-step, we take that negative 4/3 p greater than negative 10. Oops, I dropped the negative here. That's positive. Sorry about that. Negative 10. I can multiply both sides by 3, right? And those 3's cancel out, and it becomes negative 4p is greater than negative 30. Oh, shoot. Guys, look at my big, bad, ugly mistake. I multiplied by negative. I had to flip my sign. Do you see that? My big, bad, ugly mistake? Don't be me. Don't make the mistake. Okay, so I'm now dividing by negative 4, so that flips the sign. And then negative 30 over negative 4 becomes 15 halves. So you can do this in one step by multiplying by the reciprocal, or you can do it in 2 steps by multiplying by the denominator and then dividing by the numerator. Do it again.
Stop.
It's too green.
That makes sense. I was wondering why we had negative 15 on one and not on the other.
Okay, I changed it to a positive. I had dropped my negative. I made a couple mistakes on this first one. Okay. All right, so one step, 2 steps. Personally, I like 2-step, but that's just me. I have 3/8 t is less than 5. I'm going to multiply both sides by 8/3 because that's the reciprocal. So 3/8 and the 8/3 cancel each other out, and I'm left with t. 3 doesn't go into 5, so I'm going to multiply 8 times 5, which is 40, and put that over 3/3. Or in 2 steps, I multiply both sides by the denominator of 8. So I get 3t is less than 40, and then divide by 3. So as you can see, you get the same answer no matter which way you do it. It's just a matter of preference. Do you prefer to multiply fractions, or do you prefer to multiply whole numbers and divide whole numbers? Okay, we have a cheerleader, Lakita. She needs to attend at least, and so we remember at least is greater than or equal to 3/5 of the study table sessions offered. She has attended 15. If she met the requirements, what is the least amount? So, okay, so 15 is actually going to be, okay, this one's actually kind of a little bit twisted. What is the least amount of study table sessions? So you've got some 3/5 x, and she needs to be greater than or equal to 3/5 of that, but she's attended 15. And so we know that 15 is going to be greater than or equal to, sorry, backwards. 3/5 x is going to be less than or equal to 15, because if she's met the requirements, that means 15 was good enough, or less than 15 was good enough. Does that make sense? So we actually had to kind of flip that. 15 is greater than or equal to 3/5 of the. Does that help? Have I completely lost you?
No.
Oh, okay.
Right with you.
Okay, cool. 1 step or 2 step? 1 step? Okay. Yeah, they're both dependable. I'm going to multiply both sides by 5/3. So these will cancel out and I'm left with x. I multiplied by positive, so I don't have to change that. 3 goes into 15 5 times. 5 times 5 is 25. So if 15 was at least 3/5 of 25, would be the smallest number it could be. Or the largest number it could be. Okay. Make sense? Okay. You guys are okay, comfortable with graphing? We can probably skip the graph, right? Okay. Maria purchased a prepaid phone plan for $50 at 13 cents a minute. So how many minutes can she talk on the phone? 13 cents times her number of minutes has to be less than or equal to $50. So we're going to divide $50 by 13 cents. So she can talk for 384.6 minutes or less. Right?